Okay, now we're going to use the idea of the type 1 and the type 2 error to actually help us find the rejection region. That is, what the idea of sufficient evidence is to reject the null hypothesis. Okay, so just to recap, at the moment we are holding our pet belief in the alternative hypothesis. We're imagining that we will reject HO if alpha 1 hat is sufficiently large. Okay, so if the estimate based on our sample is sufficiently big, we're going to conclude that the true alpha is likely to be positive. Okay, what we don't know is how to define the idea of sufficiently big. Okay, and that's where we're going to use what we just learned about the type 1 error. Okay. So to recall, the type 1 error is the probability of rejecting HO when HO is true. So two things have to happen for a type 1 error. Number one is H1 has to be rejected. Number two, HO has to be true. Okay? So true in this case would be any alpha 1 that was less than or equal to 0. Okay? For argument's sake, we're going to assume that true means 0 at the moment. Okay, so I've centered this distribution of alpha 1 hat values on a true alpha that assumes that the null is true. Okay, so we've taken this alpha 1 hat distribution, centered it on a 0 value, and 0 is contained in the null hypothesis. So we are assuming that the null is true. Okay. Next, we're going to reject the null hypothesis if alpha 1 hat is bigger than some threshold value, which we're going to call alpha critical. You would have heard the word critical value in your statistics class earlier. So we're going to reject if alpha 1 hat, reject HO if alpha 1 hat is bigger than alpha critical. Okay? So the question is, where are we going to place alpha critical? Should alpha critical be here? Should alpha critical be here? Or where should it go? Okay? So we have to find alpha critical. Right? Now remember, we're assuming in this drawing of the distribution that the null hypothesis is true, and we can tell that we're making that assumption because we've centered it on 0, and 0 is contained in the null hypothesis. So instead of arbitrarily picking an alpha critical value, what we're going to do is we're going to set the probability of a type 1 error. Okay, so let's suppose that we set the probability of a type 1 error equal to 0.05. Well, that would mean that we're setting the probability of rejecting the null when the null is true to be equal to 0.05. That is, in repeated collections of samples, repeated estimations of alpha 1 hat, we would reject the null when the null is true about 5% of the time if we did this a whole bunch of times. Okay? How does that become useful in choosing a critical value? Well, this distribution assumes that the null is true, right? So we can say that the probability of rejecting the null when the null is true is the probability of drawing an alpha 1 hat that's greater than alpha critical, and we're going to set that equal to 0.05. And this is given that HO is true. Okay? So given that HO is true, we're centering the distribution on 0. We're going to choose alpha critical, the threshold value, to compare our alpha 1 hat to, such that the probability is 0.05. Okay? So instead of picking alpha critical, and then looking at what the probability of a type 1 error is, we set the probability of a type 1 error, and we then use that probability of a type 1 error, it would be the area under this particular part of the distribution here, to find the critical value. Okay? So the blue area shows us the probability of a type 1 error. The probability of alpha 1 hat bigger than alpha critical, given that HO is true. Okay?